Biology used to be tracked in simple spreadsheets. Today, a single experiment can generate thousands of data points in a matter of hours. Because of this high-throughput explosion, the daily life of a researcher has shifted. You likely spend less time running experiments at the bench and more time sitting at a computer trying to organize and interpret the sheer volume of data you've collected. But while the data has gotten heavier, the ticking clock hasn't slowed down. The pressure to publish your findings quickly and secure the next round of funding is as high as ever. To keep up, you need robust statistical software. Choose the right tool, and you accelerate your research. Choose the wrong one, and you drain weeks of time fighting with formatting and syntax errors. For decades, GraphPad Prism has been the heavyweight option built specifically for the life sciences to eliminate this exact bottleneck. But it's not the only option. Many labs turn to free, open-source programming languages like R and Python to handle their analyses. This chart shows how these options stack up against each other. We are looking at financial cost on the vertical axis and the learning curve on the horizontal axis. Open-source languages like R and Python sit down here. You pay $0 for the software, but you will spend hundreds of hours learning how to write the code to use it. GraphPad Prism lands up here. It requires a paid, ongoing subscription, but it gives you an immediate code-free interface. Deciding between these tools requires looking at your lab's resources. You have to decide whether you can afford to spend your budget on a license or spend your time learning to code. One of Prism's strongest arguments for your budget is its built-in statistical guardrails. The software actively guides you. By looking at the characteristics of your dataset, Prism points you toward the appropriate statistical test, helping you avoid running the wrong math on your experiment. It also emphasizes effect size reporting. Instead of just giving you a simple p-value that says whether a result is statistically significant, Prism shows you the actual magnitude of your findings. This gives a much clearer picture of your data's real-world impact. Compare that to coding in R. In an open-source environment, you are completely on your own. You have to know exactly which statistical package to install, how to call it, and how to configure the parameters from scratch. We can track these trade-offs on a comparison matrix. For statistical selection, Prism offers a guided experience, while open source relies on manual expertise. However, that guided convenience comes with a serious risk, the black box effect. Because the interface is so clean, it is very easy to just click through the drop-down menus. When you do that, you might blindly accept a result, without checking if your data actually meets the mathematical assumptions required for that test to be valid. Prism removes the friction of coding and prevents basic selection errors, but it requires discipline. You still have to do the hard, critical thinking yourself. You can't outsource your scientific rigor directly to the software. Before you even get to the analysis, you have to prepare your data. For many researchers, this is the slowest part of the entire process. If you are doing manual calculations in a basic spreadsheet to prep your variables, you introduce a massive opportunity for human error before the real math even begins. Prism tackles this with a feature called calculated variables. You can define formulas directly inside your dataset, and the software will automatically compute the new data points for you, cutting out the spreadsheet middleman. It also handles complex, multi-layered experimental designs cleanly through its enhanced ANOVA workflows, keeping everything contained within a visual interface. Adding workflow adaptability to our matrix shows another clear split. Prism relies on a standardized user interface, whereas open source offers infinite scripting. That standardized UI has a ceiling. If your experimental design is highly unconventional, you will eventually hit a wall where the menus just don't have the option you need. Here, open source is the winner. With R or Python, you can write a custom script to process and manipulate literally any data structure you can imagine. You are never restricted by what a developer decided to put in a drop-down menu. Prism is built to automate the vast majority of standard biological workflows flawlessly, but if your work consistently breaks the mold, you will need to rely on code. After the analysis is done, you still have to format your graphs to meet the strict visual standards required by scientific journals. Prism is explicitly designed for this final hurdle. It includes templates tailored to journal requirements, allowing you to generate clean, publication-ready visuals with a few clicks. Trying to achieve that same exact aesthetic in a Python library like matplotlib is a different story. Adjusting the font size on a single axis label might require rewriting 3 separate lines of code and running it again to see if it worked. Python does offer limitless visual customizability and direct integration into broader machine learning pipelines, things Prism simply isn't built to do. But for the average life scientist trying to submit a paper, the pragmatic speed and built-in journal compliance of Prism easily outweigh the need to tweak every single pixel with code. So, who exactly should be buying this software? The utility of the tool depends entirely on your specific academic discipline. This flowchart maps out the ideal software choice based on your field. We start with your primary discipline. If your work is rooted in survey data and sociology, you should avoid Prism. You will be much better served by a tool like SPSS, which is built specifically for social science methodologies. If you are in engineering or physics and need heavy mathematical graphing capabilities, follow this path. Origin Pro is going to give you the advanced toolset you need. But for biomedical researchers, pharmacologists, and those managing clinical trials, the path leads straight to GraphPad Prism. In the life sciences, your priority is the rapid, reproducible analysis of complex biological data. You need to verify your results and visualize them clearly without taking a detour to learn programming syntax. Software superiority is a myth. The context of your research dictates whether a tool will act as an accelerator or a roadblock. There is one notable exception. If you are a life scientist who already knows how to code in R or Python, and your lab has no software budget, a Prism subscription is an unnecessary expense. Stick with your code. But regardless of your discipline, keep this in mind. No software can fix flawed data. Whether you are using a free script or a costly license, you must properly clean and organize your data before you begin. If you skip that step, your results will be inaccurate. In modern research, time is often your most scarce resource, even more so than grant money. GraphPad Prism is ultimately an investment designed to buy that time back.